Hello, everyone. Today we're going to solve 2019 AP Calculus BC free response question number 1. So let's see. All right, so this is the question number 1 of 2019 AP Calculus BC. The fish enter a lake at a rate modeled by the function e given by this function, and then also leaves by this model. So let's look at question number 1. We're given two functions here, ET and LT, where T is measured in hours. Okay, so the part A, the question asks how many fish enter the lake over the 5-hour period from midnight to 5 a.m. So we are measuring from T0 to T5. We have to aggregate all the fish that entered from midnight to 5 a.m. So we can set up the equation with the integral from 0 to 5. And since we're calculating the fish entering the lake, we are using ET dt. Let's actually calculate this from our calculator. So it's 0 to 5, 20 plus 15 sine pi t over 6. And since this allows you to use the graphing calculator, you can just directly put this into your calculator, which gives you about 153.4546. So you can just say about 153 fish entered the lake during this time. So the key takeaway about this part is to find the total quantity accumulated, right? That is the situation where you have to use the integral. All right. And the part B now requires you to calculate the average number of fish that have left the lake per hour over the 5-hour period, the same hour period. How do we calculate the average here? Well, you can just think about what an average is. You calculate, so let's say we graph this model from A to B, and you want to calculate the average rate of change. Now you can, average rate of change, you can think about a straight line, right? Just the change from A to B in quantity over the certain period, which is going to be A, B minus A. So let's set up the equation. Average equals 1 over N to start, right? In this case, in our case, it would be 5 minus 0 because we are looking from 0.0 to hour 5, which is 5 a.m. So, and then we're going to put the accumulative number that gives you the total number of fish that have left the lake during the given period, which is going to be 0 to 5 LTDT this time. So you have to calculate from 0 to 5, the total number of fish that have left the lake from 0 to 5. That's going to be about 30.5 to put into the calculator. And then since we're calculating the average, you have to divide this by 5, which gives you about 6 fish per hour. Okay, now let's look at part C. Part C asks you to find the greatest number of fish in the lake in the given time frame. Well, before we think about the greatest number, let's first think about the rate of change. So literally you can think about the fish entering the lake minus fish leaving the lake. So let's just first set up the equation, rate of change as a fish entering the lake minus fish leaving the lake, right? And then how do we find the greatest number of fish? When does this happen? So think about the local minimum and maximum that we discussed. So let's say we have a graph. Maybe this graph could represent the number of fish of given time period to this interval like this. So we want to find the greatest number of fish between the time frame A and B. Well, how do we find it? As you can see, this is the maximum, right? We call this local maximum. How do we find the local maximum here? Local maximum is generally when the rate of change goes from increasing to decreasing, right? This is where the local maximum is happening. So we can bring this idea, we can apply this idea to our situation too. So the greatest number of change in the fish is given by this LET minus LT. And think about one situation where ET minus LT is greater than 0. Then this means the number of fish in the lake is increasing because more fish are entering than leaving. Or what if it was opposite? What if it was opposite like this? Then this represents the number of fish in the lake is decreasing because more fish are leaving than entering. So when does maximum occur? When this rate of change is equal to 0, where the moment of change increases, then it starts to decrease, right? Right at that point. So we can justify the maximum point happens when maximum occurs when ET minus LT is equal to 0. So how do we find a T when this happens? You can find that ET now is equal to LT, right? Because you just put LT to the other side. Let's replace these LT and ET with the actual numbers. Well, ET was 20 plus 15 sine pi t 6 equals 4 plus t 2t the 0.1, right? And since we can use calculator, you can just put into the equation solver to your calculator. And this will give you approximately t equal to 6.203. So we realize the greatest number of fish in the lake happens right around this moment. Okay, now let's look at part D. Part D is the rate of change in the number of fish in the lake increasing or decreasing at T5. So we have to find the exact moments at T equals 5. So we can take a derivative. So we can bring this equation back. ET minus dt, which is the rate of change, and take a derivative of this. So this is basically E prime t minus L prime t, right? So at t equals 5, what does this equation give? You can take a derivative and then put into this equation, right? So this will give you about negative 10.72. So what does this imply? This value is negative, right? So we can conclude that the rate of change in the number of fish is decreasing at t equals 5. Hope this video was helpful, and I'll see you next time. Thank you.